Good evening to all participants. The application we have designed is called AIP, Animal Imaginary Place, and has to do with the finding of an appropriate location for the setting up of a place which can serve as a habitat for the protection of the red deer. The red deer Carvoselaphus is one of the biggest and most beautiful species of the deer family, which is on the verge of extinction. It used to thrive in the entire vicinity of the Greek region. Unfortunately today, members of this species can only be sighted on the Mount of Parnitha in Attica and only in small numbers ranging between 20 and 30 members in Rhodope and Epirus. The red deer population has shrunk to such an extent that the species is on the verge of extinction and has been officially registered as a critically endangered species in the Red Book of Animals Endangered in Greece. The problem we called upon to solve with this application is the finding of an appropriate place to set up a national park, establishing a natural habitat for the species in question.
Initially, we're going to look into data of previous years so as to register the locations where populations of this species used to thrive. For each location, we're going to register necessary data such as geographical data, environmental data, and population size of the species. The program of artificial intelligence will assist us in comprehending which data values have a positive effect on the species population, looking for possible locations in the country which might fulfill the geographical requirements and therefore favor the thriving of the particular species, inserting the data for each location so that the neuronic network can pick out the best location for the construction of a park. Our data comes from a wide range of different sources and types. The purpose of the collection is to find areas where the deer likes to live and feed as well as areas to avoid. Collection of data from previous years from organizations such as Arcturus, WWF, etc. Environmental data is determined using weather stations. The coordinates are recorded by GPS and then transferred to Google Earth Pro, where altitude, water presence, slope, and ground cover are calculated for each area.
We can use machine learning to help us make decisions, and a key way of doing this is the decision tree. Data with low variance reveals patterns and enables us to make predictions. As data flows through decision trees, variance decreases and information is gained. Since we want to turn this into a web service, we use Python rather than Excel, so the exact same analysis can be performed in Python. To find the best location, we have opted for image recognition because it has access to satellite imaging and can search through millions of images of aerial views of land. In addition, we have a series of images that can be categorized and ranked by their characteristics. It's important at this point to understand that the neural networks that we are discussing here exist in software. The reason neural networks are so powerful is because of the extent to which connection can be made. Our application consists of three segments: a decision tree that searches for the best decision out of the data, an image recognition which finds appropriate locations, and a neural network which examines these to find the most ideal one. We insert data of past decades for various locations in Greece, where several wildlife species used to roam, and we register these locations in which red deer populations existed. The data under scrutiny has to do with the registration of the species, the percentage of flora, the existence of water, and the registration of altitude.
There is a search initiated in the vicinity of Greece through satellite images for the tracking down of appropriate places which fulfill the prerequisites which resulted from the decision tree. These prerequisites are existence of trees, undergrowth and bushes with a 50 to 70% of greenery ground cover, existence of water like springs, rivers or lakes, and an altitude higher than 500 meters. For the suggested locations, there is collected and registered data related to three main categories: natural disasters, human activity, and climate conditions. These categories are further analyzed into separate layers. This data is examined by a neural network for the final choice of the ideal location.
Rounding off our presentation, we would like to lay emphasis on the fact that our application can be modified accordingly for the search of appropriate natural habitats for other endangered species as well, just by adapting the data in relation to the specific needs and features of the species at hand. Our application can also be further exploited commercially, as in finding an appropriate location for the building of a farm, for example.